All right, we're ready to start the FBX loader. The first thing we need to do is get the mesh portion taken care of.
That's right.
So we're going to start with the Mesh.h and the Mesh.CPP. What exactly is this going to be responsible for doing, Joel?
Well, basically, this is going to hold all of our information. Of course, we're going to need transformation data.
Okay.
We're going to need to hold the weights for each vertex, so how much a particular joint is influencing everything else.
Precisely.
So basically what we're going to do is have frame information. So a particular take, let's say it has 100 frames, right?
Right.
And each of those frames has to have information about how each of those joints is modifying all the vertices.
Okay.
So we're going to have that information. So we're basically converting what FBX SDK gives us and converting into our own format.
Awesome.
So pretty much making sure that within the Mesh.h, we have with the mesh class, we have everything we need to have a completely deforming mesh with animation. And you'll notice the Mesh.h is going to look very, very similar to our SDL hierarchy, or SDL hierarchy, object hierarchy that we created a long time ago.
Scene tree.
The scene tree thing.
That's right.
So let's go ahead and create these two files. So our Mesh.h and our Mesh.CPP.
Okay.
And the classic things we need to do. If not defined, mesh underscore the legacy stuff.
Oh, I was actually thinking the same thing.
Oh, nice.
It honestly was.
So class mesh. So this is just defining the class. And we're going to need a few things here, a few different structures. The face structure that we created way back in the day, a material structure that holds all the diffuse color, the specular color, etc., and a diffuse map.
Right.
And then finally, a new thing is the struct frame.
Right.
And this structure is going to hold, like I said, all the transformation data for the bones, the weighting information for each vertex, and all that information. So let's go ahead and start blocking this in. First thing, struct material. And you definitely better understand, or at least have... I want this to be familiar.
Recognize this. It'll be more than familiar. You've done this.
Yes. KA...
And so DS
and E. KD, SE.
Right.
The shininess level.
Yep.
The alpha.
Aren't we nice?
We try to make it
We're retyping it all. We could just do a copy and paste, really.
But we're not.
Well,
because we're just nice like that. And then we're going to create a constructor for this structure.
Did I see a string?
Yes, I did. Ooh, we might as well go ahead and throw that in.
You might as well.
So include,
you can do it. It's okay.
String.h using std string.
Awesome.
So inside of here, what we're going to do is create a few default values for ambient, diffuse, specular, and emission. So float default ambient 4 equals...
And then 0, 0, 0, and 1.
Yeah, black for ambient by default.
Exactly.
Thank you.
Okay, now we're going to do default diffuse. Oh, look at you, copy-paste king.
Specular... And then we'll just fill in the values in a second here. So here we have 1.
1 and 1, all the way across the board. Okay. Next one's zeros, all the way across except for the last one.
So that's all right.
Yeah, that's all right. And the last one's all zeros.
Awesome.
Woohoo!
So we just need to set these. So mem, copy. And of course we have separate, even though they're the same, we have separate ones just in case you wanted different default values for each of them.
That's right.
So we want to copy this into KA, default ambient, size of float. How much do we want to copy? Size of float times 4. We have 4 date items.
That's right.
And simply copy and paste this 4 times. So KD, KS, and KE. And then we need to set some default values for our shininess.
Before we go too much further, let's go ahead and change default ambient to say default diffuse, specular, and emission.
Whoa.
That'd be a big line.
Diffuse, specular, and emission.
Beautiful.
For our shininess, I'll set this to 2.0F. For alpha, I'll set this to 1.0, so full visibility, and illumination is going to equal 1.0F. Okay. And another thing, notice we're using a texture here, so let me go ahead and throw in my include for my texture.
Very nice.
And another thing I'm going to point out is, remember before we had ambient map, alpha map, transparency map, all that extra maps. Of course, we weren't using that, but in the OBJ loader, we decided to put those in as a placeholder. In this case, I mean, we're just definitely going to only use diffuse map.
Yeah, well, you guys already know how to do this.
Right.
Let's just be honest, okay?
Yep.
So we won't waste any time on that.
Right, because we know how to use it.
Exactly.
So let's go ahead and set this diffuse map over to null,
okay,
just as an initializer. All right, so here we have our material class. Now, let me go ahead and create my struct face, because this is, again, something that you've probably seen. Well, you better have seen before.
Yeah.
Struct face, and this is going to hold the face information, so which vertex is connected to which vertex, etc. So the first thing is int vertices 3. Mm-hmm. So basically, these hold 3 indices into our vertex array that we're going to be printing. And again, 3 ints for our normals.
And UVs.
And 3 for our UVs. And then, of course, we're going to have a material pointer for each face, because remember, each face can have a different material.
That's right.
And we're going to store our face center and our face normal.
Oh, I smell another include coming.
Probably so. Face normal. And let me go ahead and create a constructor here. So we're going to pass it the indices we need. So int x, int y, and int z. So there are a few differences from this one and the previous one that we created. So basically we're using indices to point into an array. That's all you really need to know. Mm-hmm. And we'll be seeing how to use this in a minute here. So int n1, so indices for our normals, and n3. And finally we have our UV coordinates, so UV1, UV2, and UV3. And finally we need a list of vectors. Let's see here. Vector pointer v. Mm-hmm. And of course, since we're only storing the indices, it's not really necessary for us to know exactly what the vector is. But since we're calculating the normal and the face center, we need to go ahead and know those vertices. So inside of here, let's go ahead and set vertices 0 equal to x, 1 and 2 to y and z. And let me just copy this whole thing.
Yeah, and do the same for normals and then for UVs.
Right. So normals are going to equal n1, n2, and n3.
Right.
Let me just copy this whole thing again. It's kind of similar. So our UVs, that's going to be set to UV1, 2, and 3.
Okay.
So there we have it. So now we've set up the indices. Now let's go ahead and calculate the face center and face normal. So let's go ahead and do a loop to calculate the face center. And we've done this before, so it should make total sense to you. So the face center is going to add all the vertices together, so simply vertices I. So we're getting the index, this index, into the vertex array, adding that to face center, and then we're finding the average position. So at the end, simply do face center divide equal 3.0f. Mm-hmm. And then we're done. Then calculate the face normal. We simply take the cross product. So this one's going to equal, let's see, Vx, which is what was passed to us, the first index, minus Vy, and we're going to normalize that. And this is going to be multiplied by, let's see, Vx minus Vz. And we're going to normalize that as well. And then finally, we're going to go ahead and default the material over to null.
Okay. And before we get too far away, let's go ahead and throw the include in for vector 3 up at the top.
Let me come up to the top here and just add in a vector 3.
Cool.
Awesome. So let me go ahead and try to compile this. Actually, let me go to STL demo just so we can kind of do this in a slow kind of fashion here. So include mesh.h. Just make sure everything works properly. Oh, check it out. But we need to go ahead and include mesh.h here as well, just so the CPP file compiles. Awesome. Okay, good. All right, so we've got it pretty much working so far. Mm-hmm. Well, it is working so far.
Exactly.
So let me go ahead and add in my frame structure here. So struct frame, and this one's the simplest one of all of them. It's very simple. All it needs to hold is the matrix deformations and the weights. Now, we could go ahead and create our own matrix class, but the matrix class that comes with the FBX SDK works fine. And if you want to create your own matrix class that basically replaces everything in the FBX one, you can go ahead and do that. I mean, no one's stopping you from doing that. It's just preventing us from having to implement yet another class. So KFBX X matrix, bones, and double, weights. And of course, this is holding the weights for the vertices.
That's right.
And then bones, this is going to hold the transformations for the bones at each frame. And of course, we're going to need a list of frames inside of our mesh class, which leads us to the mesh class. What kind of things are we going to need here? Well, let me define my sections here. So we're going to have our public section, our protected section, or private, whichever you prefer, and our public section for our vertices, our member variables, if you will. Things that we need, well, mesh, a constructor, passing it a name, some sort of name, the destructor, and I'm creating this as virtual just in case you want to create children of mesh, different kinds of variations of mesh. So we have mesh destructor, and we need to draw this mesh. And what's cool about splitting it up into an FBX loader and the mesh class is that the mesh class can handle the drawing of it, and the FBX loader can handle only the loading of the FBX file.
Right.
And so it's kind of segmented off, which is really nice. So in here, we're going to need to draw the mesh. And we're going to pass at vector3 a list of vectors called transformed verts. All right, what does this mean? Well, inside of the mesh class, obviously we're going to have a list of transformations of the bones and the weights for these. Now, inside the FBX loader, it's its responsibility to get the current frame that we want to render, transform the vertices, store it inside of here, and send it back over into draw mesh. And this will all become clear if that doesn't seem to make sense at the moment.
Actually, not bad.
Make sense?
Yeah.
Okay. So inside of vector3, this is going to hold all the vertices that are transformed to the proper location at the current frame.
Right.
Then we have some accessory functions. So a vector face pointer. So just return all the faces. We want to be able to get all the vertices. So simply return all the vertices. I think this is supposed to be capital. Thank you. Void. Let's see. What else do we have? Get normals.
And get UVs.
Awesome. Now, okay, so let me go ahead and switch back over into my public section real quick here for my variables, just so you can see what variables we have. Of course, we're going to need a list of all vertices.
That's right.
So we have a vector3 list of vertices. Let me just kind of tab this over a little bit more. And a vector3 list of all normals.
And the same for UVs.
Yep. And we're also going to need to store the number of vertices we have. So just num vertices. And a list of all the faces. Again, this is going to be very similar to when we did the hierarchy lesson. So faces. Something to hold the name of our object. And some new information.
Mm-hmm.
We need to know at what frame the take or this particular take starts.
Right.
When it ends, and the current frame we're on, and the list of structures here that hold for each frame the deformations and weights that we need.
Right.
So we can just put in new information. So here we have the frame start. We have the frame end.
And the frame.
The frame. And a list of all the frames. So, frames. And of course, I'm making this public just so that the FBX loader can easily access all of this information. Of course, I do have accessory functions that can be used here, but at the moment, it's just convenient to have all of this information directly accessible to us. And so at this point, let's go ahead and add one more thing in here. So add face. And of course, in a second here, we're going to be using this inside of our FBX loader in the next lesson. So add face. And in here, we simply pass it the indices. So V1, V2, V3, N1, int, N2. I know, extremely exciting stuff.
And then UV1, 2, and 3. And then the material.
So very much similar to the constructor for our face. It's just kind of conveniencing it. Making it more convenient, excuse me.
No, I like that. Conveniencing it.
Awesome. Or we can have a separate add face that simply passes a pointer to it. So,
nice.
Face pointer. Finally, under the protected section or private, whichever you prefer, we say delete objects. And this is going to delete all the objects that we've created.
Right.
Okay, so that should be our header file. Now, of course, we're now using this KFBX matrix,
right?
Which means we don't have access to this just yet. So let me go into my SDL demo. Let me get rid of all this stuff. I don't want the main demo to ever have to think or worry about the FBX SDK. Its job is simply to include FBX loader, load in the mesh, and never have to worry about FBX.
That's right.
So let me come over to my mesh.h. and just throw this in here. Or let me just throw this into the top just to make it more pronounced.
There we go.
Let me go ahead and try to compile this. It's not going to find it, so the linking won't work. Oh, unless, of course, we're not creating the mesh anywhere, so it doesn't need to.
Right.
So the header file seems to be doing just good. So let's go ahead and copy all these functions so we know the definitions and start implementing them in Mesh.CPP. This is where the fun begins, mostly.
Just a couple lines to type here, folks.
Yeah, just a few.
Just a few. 3,000. No, I'm just kidding.
Not that many.
I know, it's like 30,000. People are like, oh, man, that's it. I'm done watching.
Yep, fast forward.
Oh, my bad. Yeah, that's right, the filler verbiage. So, yeah, the weather's been pretty good today, and Joel is doing the standard thing he always does as he cleans up all of his functions here in the CPP file. Yes, that's right, ladies and gentlemen. Now he's going to scope it in. Look at him go. Yes, awesome.
Scoping. Done. All right, so we've got everything scoped in. And just real quick here, we can throw in a test mesh. And let me try to go ahead and compile this, make sure everything's okay. Awesome, it's not. Let's see. Okay. Do not redeclare virtual, and do not redeclare default parameters. Oh, wow, I messed that up. Scope, then the destructor.
It's okay. We've been up for a very long time.
Yeah, no kidding. Okay, let me just kind of return some default values here. Get faces. We can start just implementing these because these are really simple. Return the number of faces, or return the faces. So simply return faces. This is really hard. I don't know if we can handle it.
I'm having a hard time here.
Return normals.
Ooh.
See, I told you these functions are easy.
UVs? Ooh.
Oh yeah, you're good.
Yo, thank you. Yes.
Let's try to compile that. Awesome.
Oh,
totally working.
You are so jamming.
I know.
You're on fire.
All right, so let's start implementing some of these. First off, the constructor. Well, we only really have one thing, a few things actually that we need to kind of initialize. We'll go ahead and initialize these to null and set the num vertices to something. Okay. So let's take all of this, come over to here, just so we have something to reference. So vertices equals null. I like doing that just so I don't forget something. Nil. There we go. UVs equals null. And we'll just set the num vertices equal to 0.
Okay.
Now let me just delete this out.
Cool.
All right. And the destructor, well, we call delete objects.
Wow. Joel, you're making this so complicated.
No. Let me go down, and before I do the draw mesh, because that's really the most complicated function here.
Right.
Let me go to add face. And this is really kind of simple. All we need to do is create a face with the values that were passed to us. So let's create a new face. And simply pass what was passed to us. So V2, V3, N1, N2, N3, UV1, UV2, UV3. And for this, we simply pass it vertices. And guess what? We're done.
Yep.
And then we can set the face material to whatever was passed to us. So face material equals material.
And push the face.
Push the face onto our faces list, or vector. Done.
Excellent.
And for add face, this is even more easy. Faces.pushback. Faces.pushback. Pushback, thank you.
You can do it.
Face.
Cool.
And let me just kind of clean that up a bit. There we go. Alright, so let me go ahead and compile this, make sure it works. I just like compiling a lot to make sure I'm on the right track. Alright, so we have that. Now what we need to do is, let me go ahead and complete the delete objects. This is fairly simple. We need to delete all the vertices. So delete the array of vertices.
And the normals and
delete
the UVs.
all normals. Delete all UVs.
Then we need to loop through and delete our faces.
So for int I equals 0, I is less than int faces dot size I plus plus. Sound like a computer here.
Yes, you do, but that's okay.
Delete faces, and then we can simply clear this out.
Yeah.
And of course, so right now we're only calling this in the destructor, but what if you wanted to delete the object and repopulate it? So we're going to need to clear the faces list.
That's right.
So that the old data isn't still there. Well, because we've just deleted everything. So finally, there's only one thing left, and that is draw mesh. And this is, again, something that you have seen before, so it's not going to be a total shocker what we have here. First thing, push our model view matrix.
Right.
So let's set our matrix mode and do a GL model view and push our matrix. And let's go ahead and throw in our GL pop matrix as well, which is going to happen at the very end.
Sure.
All right, so let's go ahead and loop through all the faces and start drawing these. So let's do a for int I equals 0, I is less than int faces.size, I plus plus. All right, so inside of here, first let's get the face we want to work with. So face equals faces I. And of course, now we have access to all the vertice indices that we need.
Mm-hmm.
So we can go ahead and do a GL begin, GL triangles. And then there are two conditions here. One condition is if we want to draw the transformed vertices. So if someone passes something to our transformed vertices, then we need to go ahead and draw those. Otherwise, we just draw whatever is inside face, which means there's not going to be any deformations.
Let's stay consistent going through the GL ending as well.
Oh, yeah, thank you. So before I forget, because I would.
Because there's quite a few lines coming.
Yeah. So inside of here, first thing we're going to do is check to see if the transformed verts does not equal null. If it's not null, obviously that means we want to use it.
Mm-hmm.
Otherwise, we won't use it. And now we simply need to loop through. And of course, all of these are triangles. So we simply need to loop 3 times. So for int v equals 0, v is less than 3, v plus plus. And then for every single one of these vertices, we need to do 3 things. Called set the normal, set the texture coordinate, and set the vertex. So we have our GL text core to F. And then we have our UVs, right? So this is the list of vertices that we have. What we need to do is get the index that we want. We have our face, get its UVs, and get V, which is between 0 and 3.
Right.
It looks complicated, but it's really not that hard. And then we simply get its X coordinate. And then for the Y, same idea. Simply copy, paste this, change this to a Y, and we're done. And we do pretty much the same thing for normal and vertex. So GL normal 3D, normals, and then face, normals, V, dot X. Okay, it's looking very complicated, so I'm just pausing for a second here. So let me copy this. Let me paste it on the next line just to kind of...
Yeah, it makes it look a lot cleaner.
Yeah. And Z, and if that looks right, yep, I think so. Let me just copy and paste this for GL vertex. Vertex 3D. And instead these are going to be vertices. So vertices, vertices. And of course we want to access the right variable as well.
Right.
So there we go. Now one other thing we need to do, actually I'm accessing the vertices here. What I want to be doing is accessing the transformed verts. Let me just copy and paste this for the non-transformed verts, because that's almost exactly right, because I'm utilizing the vertices that are static.
Okay.
If transform verts is not null, then what I need to do is use that list of vertices. So just change that to that.
Exactly.
The indices are obviously going to remain the same. So.
Right.
And then what I need to do is texture coordinates. Well, these aren't always going to have texture coordinates. Sometimes you don't have texture coordinates, so we need to make sure. Otherwise, if faces UVs is -1, for example, then this call is obviously going to fail. We're going to get an error, and our program's going to end.
Exactly.
So what we're going to need to do in here is just add a simple check that says if face UVs does not equal V. Does not equal -1, then go ahead and use it. You could do the same test for the others, but I'm confident that we always have a normal and a vertex.
That's right.
And let me go ahead and throw this test in for this one as well. All right, so let's see. What else do we need here? Let me go ahead and end that off. And another thing we're going to need to do is return true, because obviously it worked. Is there anything else I'm missing?
I'm looking. And it's
nope, it looks like I got everything.
Good, yeah.
So again, just as a recap. Oh, well, one thing. I almost missed this entirely. We got our triangles drawn, but of course we have a material as well.
Oh yeah, you jumped right past.
I jumped right past that. So we have our material, let's go ahead and get a material equals the current face's material. And again, we're going to have to set up a whole lot of things here. So what we're going to do is store the last material. And if the material of this face is different, then change it. Otherwise, just leave it the same. Otherwise, we're going to have to change everything constantly, and that slows everything down. So we do a last material. We start that out as null. And then we say, if material does not equal last material, then go ahead and set last material equal to material, and go ahead and set everything. So if there's a diffuse map, so if this material has a diffuse map, in other words, it does not equal null, then let's go ahead and enable textures. You've probably seen this 3,000 times now.
At least.
Let's go ahead and bind the texture. So GL bind texture, GL texture 2D, and then pass it material, diffuse map, and then we get its text ID. Done. Otherwise, if there isn't a diffuse map, we're going to disable its GL texture 2D.
And then set last material.
Yep.
You already have. Good, excellent.
So there. Of course, we also have the diffuse color and... let's see, let me just go back up here so you can see it. We have the diffuse, default ambient, default diffuse that we have here, K, KD, KS, and KE. You can go ahead and throw that in as well. I just haven't in this case because, well...
We're just simplifying.
Just simplifying to make it easy, because we've seen this a million times.
It's the same thing.
Yep. So let me go ahead and try to compile this and see how many errors I got.
I don't know, man. You're on fire.
I am
What'd I tell
fire.
You?
Awesome.
Wow.
So now we have our mesh class, and in the next lesson, what we're going to be doing is taking a look at creating the FBX loader, which is going to utilize the mesh class to hold all our data. So it's going to be creating our mesh, it's going to be sending all the information we need to the mesh, and then calling mesh to draw the mesh.
That's right. Woo.
Lots of stuff.
Yeah, exactly. So that's everything we needed to do to get the mesh class in place, and that's going to wrap up this video. Thanks a lot.